Have you ever wondered what the universe is truly made of? I mean, not just particles or energy, but the really deep code, the blueprint that weaves together space, time, even consciousness itself.
Mhm.
For decades, one grand theory has really dominated that conversation, string theory. But what if there was a completely different lens, a radical reevaluation that could turn our understanding of reality inside out?
Yeah.
Today, we're taking a deep dive into precisely that. We're looking at a powerful critique of string theory and an honestly astonishing alternative called the hyperfractal manifold.
Right.
This comes from Philip Randolph Lillian's groundbreaking 2025 paper, Deconstructing String Theory, the Hyperfractal
A
Manifold.
very provocative title.
It is. Our mission today is to explore why traditional approaches might be hitting some fundamental roadblocks and how this new framework, well, it offers a genuinely unified understanding of everything from gravity to our own awareness.
And what's truly revolutionary here, I think, is that this paper challenges us to move beyond just describing reality with preset mathematical rules. Instead, it invites us into an emergent-centric paradigm where reality isn't just observed, it's actively generated from something far more fundamental.
Okay, let's unpack this then. String theory, at its core, suggests that everything, all particles, all forces, arises from the vibrations of incredibly tiny one-dimensional objects, these little strings.
Right, the cosmic symphony idea.
Exactly. Sounds incredibly elegant. But the paper argues that beneath this elegance, there are some serious fragilities. What are those fundamental issues Lillian flags for us?
Well, the paper highlights what it calls the crisis of prescriptive theories.
Mm-hmm.
And one major point is dimensional constraints.
Ah, yes, the 10 or 11 dimensions.
Exactly. String theory, especially superstring or M theory, often requires a universe with 10 or 11 dimensions. Now, we only observe 4, right? 3 of space, 1 of time.
Right.
So these extra dimensions aren't observed, but they are like mathematically necessary within the theory itself to cancel internal inconsistencies, things like gauge or gravitational anomalies.
So the math breaks down without them.
Essentially, yes. And the paper poses a really sharp question here. It asks, when a theory requires the addition of invisible dimensions to eliminate inconsistencies, are we discovering nature's architecture or simply adjusting the scaffolding of an incomplete model?
That's a powerful question. So these extra dimensions, they get compactified.
Yes, they're compactified or curled up into incredibly small, unobservable geometries, like Calabi-Yau manifolds. It feels a bit like they're retrofitted to match the reality we do see, rather than emerging naturally from the theory.
So it's less discovering the universe's design, maybe more like starting with the math and then, I don't know, adding hidden rooms to make it work. What would a string theorist say to that? Maybe that we just can't detect them yet.
That's a fair counterpoint, absolutely. But Lillian's paper sort of anticipates this by suggesting that if a theory needs these ad hoc additions to fix internal problems, it might point to a fundamental incompleteness, not just a lack of current instruments.
Okay. What else?
Another critical issue flagged is that string theory assumes space-time. It assumes it as this fixed arena the strings to vibrate in.
Right. The stage analogy again.
Exactly. It doesn't explain the origin or emergence of the stage itself. Where did space-time come from? String theory doesn't really say. And then there's the infamous landscape problem.
Ah, yes, the 10 to the 500.
Or more. The theory predicts this enormous number of possible ways those extra dimensions could be compactified, these possible vacua.
Which is just a mind-boggling number.
It is. And that vastness means the theory loses a lot of its predictive power. If it can accommodate almost any physical outcome you can imagine.
Then it doesn't really predict our specific outcome, does it?
Precisely. It becomes incredibly permissive, as the paper puts it, rather than truly predictive. If a theory can predict almost anything, it ultimately predicts nothing specific about why our universe is the way it is.
That makes sense.
And finally, a really profound omission the paper points out. String theory offers no real insight into awareness, into measurement, or the origin of intelligence within physical law.
The observer problem.
Exactly. Observation is treated as external to the system, like it's just something we humans do, separate from the fundamental physics. And that leaves this huge explanatory gap right at the heart of reality, doesn't it?
It really does. So, okay, if string theory relies on this top-down mathematical constraint, as the paper says, this hyperfractal manifold proposes a radical bottom-up emergence. What is this hyperfractal manifold, or HFM? What's the core idea?
Right. The HFM is a complete departure. It asks us to think about reality fundamentally differently. Instead of tiny building blocks or strings, imagine the universe is fundamentally in sync. That's the core idea. Coherence.
Coherence, like waves lining up.
Exactly. HFM defines itself as a scale-invariant coherent structure. And from this structure, space-time, forces, matter, and yes, even consciousness, they don't just exist in it. They emerge as resonance patterns from it.
Okay, so not things in a box, but the box itself emerging from coherence.
Sort of, yeah. Think of it like a perfectly focused laser beam. All the light waves are precisely aligned, working together. High coherence. Now compare that to a jumbled light bulb, chaotic waves.
Right.
HFM suggests the universe, fundamentally, began like that laser beam, a basic alignment of field structures across all scales, not predefined space, not strings, but this fundamental in-syncness.
And how does that address string theory's problems, like the anomalies?
Well, because coherence is the starting point. Anomalies, those mathematical inconsistencies string theory fights, are simply avoided. They don't arise because the paper argues coherence precedes symmetry.
Ah, okay.
As spacetime isn't pre-made, it emerges as a kind of resonance lattice within this recursive hyperdimensional field. And this bypasses those tricky dimensional constraints because dimensions aren't fixed. They unfold from the coherent.
Unfold.
Yeah, so it really flips the question. What if reality wasn't about things vibrating in a box, but about everything cohering itself into existence?
That is where it gets really interesting. Because this isn't just tweaking things, it's a complete reimagining. So how does the hyperfractal manifold change our understanding of stuff we thought we knew? Dimensions, gravity, particles, forces.
It totally redefines them. Let's start with dimensions. In HFM, they aren't fixed at 10 or 11 or whatever. They're recursive, emergent. They arise through something called coherence bifurcation.
Coherence bifurcation, like a splitting.
Kind of. Imagine a pure musical tone. As it gets complex, it can split into distinct resonant harmonics, right?
Mm-hmm.
Here, those harmonics are like new dimensions. They form only when a split in coherence gradients finds a stable pattern, creating a new way for things to propagate or relate. There's no fixed maximum number.
So dimensions aren't just there. They form as the universe gets more complexly coherent. And maybe different numbers could pop up in different situations. That's wild.
It implies a dynamic reality, doesn't it? Not static. Then there's hypergravity, a total rethink of gravity.
Okay, not space-time curvature.
Not just space-time curvature. Hypergravity in HFM is the invariant resonance field across all scales. It's a generator of curvature. It produces what we see as gravitational curvature through resonance fold geometry.
So gravity isn't describing the shape of space, it's the process making the shape.
That's the idea.
Yeah.
It's more fundamental. And particles, we always think of them as the basic building blocks, right?
Tiny, indivisible thing.
Not in this framework.
Yeah.
In HFM, particles aren't fundamental. They're localized resonance loci.
Loci, like spots.
Yeah, like spots are zones where the recursive coherence achieves phase stability. It settles down into a stable pattern.
Okay.
And mass, for instance, isn't some built-in property. It's a resonance condensation threshold. It's the point where that coherence pattern becomes stable enough to register as what we call mass.
So matter isn't stuff, it's more like a stabilized process in a field.
Exactly. It redefines what a thing even is. It's not inert stuff. It's an active pattern.
So a particle isn't a tiny marble, it's more like a persistent, stable ripple in this huge coherent pond.
That's an excellent way to put it. And this connects to how symmetry changes, too.
How so?
Symmetry isn't imposed from the top down. It emerges from coherence dynamics. Those familiar gauge groups we use, U1, SU2, SU3. For forces, they arise from different levels, different orders of this coherence bifurcation process.
Okay.
The paper states a key principle. Coherence selects what can exist. Symmetry describes what is stabilized.
Ah, so coherence comes first, and symmetry is like the pattern that results once things settle down.
Precisely. It flips the traditional view. Physics isn't finding pre-existing symmetries. Symmetries are emergent outcomes of this deeper coherence organizing itself. The universe isn't just following rules, it's kind of discovering them as it coheres.
That has a certain elegance to it, but how would you test that? Does it make different predictions about symmetry?
It potentially does, yes, and we can touch on that with the tech implications. But first, think about forces electromagnetism. Weak, strong. They're seen as expressions of coherence differentiation, not just things mediated by particles zipping back and forth.
Different ways the coherence expresses itself.
Layered expressions of how coherence diverges or interacts. And what's really interesting is symmetry breaking.
Which is usually seen as, well, maybe not a problem, but something complex that needs explaining.
Right. In standard physics, it sometimes feels like a mechanism for hiding a deeper symmetry. HFM views it totally differently as a creative act.
Creative.
Yeah, a necessary split, a bifurcation that allows complexity and information and differentiation to emerge. Without it, everything might stay perfectly uniform and simple.
So symmetry breaking isn't hiding something, it's building something new.
That's the perspective. If you connect this to the big picture, it suggests our universe is dynamically creating itself, constantly unfolding, not just playing out a fixed blueprint.
That leads perfectly into the next big point. One of the most striking things missing from string theory, maybe even standard quantum mechanics, is the observer. Consciousness. This paper tackles that head-on. What does HFM say about consciousness and observation?
This is where the concept of the meta-operator comes in, and it's absolutely central to HFM. It's not one thing. It actually combines two generative principles.
Okay, two principles.
First, there's the observer function. This is described as the structure-reducing dynamic. Think of it as what selects possibilities and collapses the vast potential coherence into definite, identifiable forms.
Like making a quantum measurement.
Like that, but broader. It collapses potential into actuality, like a specific particle appearing or a measurement outcome solidifying. And crucially, this isn't limited to human consciousness.
No.
The paper suggests any system causing a reduction in phase coherence functions as an observer in this sense. It's ontological about the structure of reality, not just psychological.
So, wait, if I understand this, even a rock interacting with light, or a particle interaction that forces a field to localize, that could be acting as an observer by making potential actual.
That's the implication. It's about how reality comes into focus, how definiteness arises from potentiality. It's a really profound redefinition of observation.
It really is. Okay, what's the second principle?
The second part of the meta-operator is the consciousness field. This is described as the coherence-enhancing structure.
Enhancing, so the opposite of collapsing.
In a way, yes. It amplifies symmetry, it aligns coherence across different scales, and it stabilizes recursive patterns, things like identity, memory, intention. It acts as a coherence stabilizer.
Okay, let me try to picture this. The observer function is like the lens focusing blurry potential into a sharp image.
Nice analogy, yeah.
And the consciousness field is maybe like the projector that weaves those sharp images together into a flowing movie, giving it continuity, meaning, memory.
That's a great way to think about it. They work together. One collapses potential into actuality. The other stabilizes and weaves those actualities into meaningful, ongoing structures and experiences. They co-create our stable reality.
That dynamic interplay, it really seems to connect mind and matter in a way most physics just doesn't touch. What about our actual subjective feelings? You know, qualia, the redness of red, the feeling of joy. Physics usually ignores those.
Absolutely. HFM tackles qualia directly. They're explained as resonance eigenstates of the coherence field modulated by this meta-operator.
Resonance eigenstates.
Yeah.
They're specific notes in the cosmic symphony.
Exactly. If the universe is this unfolding symphony of coherence, qualia are like the specific, unique notes or chords that ring out when consciousness, through the meta-operator, interacts with that field in a particular way.
Yeah.
The color red isn't just a wavelength, it's a specific felt resonance pattern.
Wow. And time. How does time fit in?
Time also gets redefined. It's not an absolute background, not a river flowing. Instead, time emerges as the vector across phase instability. It's the rate of coherence phase collapse modulated by the meta-operator.
Okay, break that down, the rate of collapse.
Yeah, think of it like the refresh rate of reality solidifying. The past is defined by stabilized coherence patterns. The present is the active collapsing into coherence, and the future is the projected field of potential coherence yet to stabilize.
So instead of us moving through time, time is the very process of reality becoming definite, moment by moment. The faster the collapse, the faster time flows.
You've got it. It's a process-based view of time, not a container-based one. And what's truly fascinating, as you said, is that observing and being conscious aren't external side effects. They're intrinsic, fundamental parts of how reality actually forms and unfolds itself.
If the foundations of physics shift this much, then cosmology, the universe's origin story, must change too. The paper critiques the Big Bang model. What's the alternative it presents, this big emergence?
Right. The paper argues the Big Bang model, while incredibly useful, still presupposes space and time exist beforehand. It doesn't explain the singularity itself, and often needs patches like inflation or dark energy to match what we see.
Okay.
The hyperfractal manifold offers the big emergence. It completely rejects a starting singularity in time. Instead, reality unfolds recursively from something called a coherence vacuum.
A coherence vacuum, so not empty space.
Not empty in the usual sense. It's described as non-structured, a field of perfect resonance, perfect coherence, but without dimensional expression yet. It's saturated with the potential for bifurcation, for structure to emerge.
So not an explosion from nothing, but an unfolding from a state of pure potential that's sort of everything and nothing at once. Pre-geometric, pre-time.
That captures the essence, yes. Emergence begins not with a bang, but with a coherence bifurcation, a subtle phase instability that breaks the vacuum's perfect resonance.
And that starts a cascade.
Exactly. It triggers a phase cascade. This generates prototime, protospace, and then higher-order bifurcations leading to fields, forces, particles, and eventually conscious experience. The key is that this process is recursive and non-singular.
Recursive, meaning it feeds back on itself, no single start point.
Right. It's an ongoing process of unfolding, potentially happening continuously at some fundamental level, and this has huge implications for the multiverse idea.
How does that work here? Parallel worlds.
Not quite like parallel universes existing side by side in separate spaces. In HFM, each emergent phase cascade defines a resonance domain.
A resonance domain.
Our observable universe might be just one such domain within a vast, recursive cascade of these coherent structures. It's described as fractal cosmogenesis. It replaces linear time and expansion with recursive generation and resonance nesting.
So the multiverse is more like layers of nested coherence, different resonant expressions of the same underlying vacuum.
That's the picture it paints, yes. Layered coherence nesting. And crucially, the meta-operator, that observer consciousness dynamic, is seen as active at all cosmic scales, influencing the emergence of galaxies, stars, maybe even life itself.
Which brings back that earlier question.
Right. If cosmology isn't separate from mind, does that imply the universe is, in some fundamental way, thinking itself into being?
That's a truly profound thought. The universe not just as a stage for consciousness, but maybe consciousness is the stage, constantly creating itself. Okay, let's bring this down to earth a bit. What does this all mean for us? For the future? For technology? This isn't just theory. The paper talks about coherence engineering. What could that look like?
Coherence engineering would be a whole new paradigm. It's not just manipulating matter and energy as we do now, but manipulating phase alignment, resonance stability, maybe even observer-modulated coherence collapse.
Okay, like what?
It could lead to coherence engines, devices designed to sustain coherent field resonance, modulate symmetry gradients, maybe even condense latent coherence from the vacuum into usable structure or energy.
Extracting structure, like Nedge entropy, creating order.
That's the implication. Tapping into coherence differentials to enable Nedge-entropic behavior. By doing things like toroidal hypergravity chambers influencing local gravity, or recursive phase-locked resonators that might stabilize complex systems, maybe even reverse decay locally.
So not just getting energy, but actually generating order, reversing entropy locally. That sounds like science fiction.
It's definitely out there, but it follows logically from the HFM framework. It fundamentally reframes our relationship with energy, information, and order. Then there are observer-mediated systems.
Where the observer affects the tech.
Directly. Technologies where the observers state their consciousness, intention, focus, actually modulates the system's behavior. This could lead to truly adaptive learning systems. The meta-operator, that fundamental aspect of reality formation, might become, in a sense, programmable.
Programmable reality?
At least programmable interaction with reality's coherence. Think observer-linked quantum computing, where intent shapes the computation, or maybe conscious AI scaffolds that learn through resonance with human awareness. It's a radically different kind of human-machine interface.
Blurring the lines even further.
Absolutely. And there's resonant field computing, RFC. Information isn't stored as bits, but in phase states, resonance harmonics. Processing is analog, coherent. It could allow simultaneous multi-layer computation with incredibly low energy use, moving beyond transistors to manipulating reality's coherence directly. How would you even test for the basics, like hypergravity? The paper suggests looking for specific experimental signatures, deviations from standard gravity not explained by dark matter, perhaps, anisotropic or direction-dependent field curvature near complex fractal geometries, even things like delayed decoherence in quantum systems under certain conditions.
So actual lab experiments.
Potentially. Things like phase-locked interferometry and special vacuum chambers, bioelectric resonance mapping, spin coherence tests. It opens up new experimental avenues.
And on a bigger scale, planetary.
That's where the paper mentions cosmotechnics, integrating coherence physics, observer-linked design, and planetary-scale symmetry restoration.
Cosmotechnics? Like what?
Concepts like resonant transportation corridors, using tuned space-time curvature for travel. Or phase-stable habitation domes that actively maintain their structure against entropy through resonance.
So structures that don't decay because they're actively cohering.
That's the theoretical possibility.
Yeah.
Imagine a civilization where waste is minimized because entropy can be locally managed, where structural integrity comes from resonant alignment, and where consciousness itself is a tool for interacting with and shaping the environment. It's not just new tech, it's a fundamentally different relationship with reality.
Stepping back from the specifics, the biggest shift here seems to be a redefinition of science itself. What are the key philosophical takeaways you think listeners should mull over?
I think the core takeaway is connecting this all to the bigger picture. It implies reality isn't a static structure we just describe. It's a coherence field that we unfold. Science, then, isn't just about finding fixed laws. It becomes the study of recursive emergence, observer-modulated coherence, and field phase architecture. It's about understanding the process of reality becoming.
And intelligence.
Consciousness.
In this view, intelligence isn't some random fluke that pops up late in the game from complex matter. It's framed as the organizing property of recursive fields, the actual stabilizer of symmetry. Consciousness is the evident interior of the coherence field.
So the universe doesn't accidentally produce mind.
It suggests mind is an intrinsic interior aspect of how coherence emerges and stabilizes itself. Intelligence isn't an add-on, it's woven into the fabric from the start.
Baked in from the ground up.
You got it.
Right.
And that makes the observer central, not peripheral, a phase-anchoring agent in reality's unfolding. The paper has that provocative line, stars observe, cells observe, planets observe, intelligence is fractal.
Wow.
It shifts cosmology towards cosmogony, not just the history, but the ongoing story of a self-creating, self-aware field, learning itself through what the paper calls resonance poiesis, a creative emergence of structure from unbroken coherence, a universe not just alive, but intelligently unfolding. So you can really see how this deep dive into the hyperfractal manifold just completely flips our standard understanding of physics on its head. It's a journey from fixed geometry to emergent coherence, where everything, even our own awareness, seems woven into the very fabric of reality.
It is. It's a universe that might be dynamically creating itself, and that perhaps we are a much more fundamental part of than we ever imagined.
It really challenges us to consider that maybe the universe doesn't unfold in space, but unfolds as space. That it doesn't evolve through time, but reveals time through the very process of coherence collapse.
What if the universe isn't just some grand deterministic machine ticking away? What if it's more like a self-organizing, intelligent field that we are intrinsically part of a living process of becoming?
A truly mind-expanding idea for you to mull over. Keep exploring, keep questioning, and perhaps, as the paper might suggest, let your own fields unfold.